Welcome students. Welcome to the fourth lecture of third module. That is, we are in the subject fluid power system. So the third module which we are doing here is components and hydraulic circuit design. So today we are going to cover the topic that is flow control valves. Okay. So in the earlier classes we have discussed about the direction control valves, then pressure control valves. So as we know, the direction control valves are mainly used to control the direction of fluid. Okay. So if you come to the pressure, it is relatively controlling the pressure. Okay. So it is a pressure control valves. So now the last type of valve, it is the flow control valves. So the main work of this flow control valve is to control the flow of a fluid. As per the flow control valve in a hydraulic system is to regulate the speed. Okay, so why we have to control the flow? As we know, all the operations which are considered, for example to and fro operations, so in many industries we have a lot of operations, so those operations have some slower speed and which are having some higher speed. Okay, so with respect to the application, so those slow speed and high speed can be adjusted, can be controlled only by flow control if it is a hydraulic system. Okay, so we have to use the flow control valves that controls the speed of that motion. Okay, so all the devices discussed here control the speed of an actuator by regulating the flow rate. Okay, the flow rate is going to be regulated. By that regulation, the speed of actuators can be controlled. Okay, so that is the purpose of using flow control valves. Flow rates also determines the rate of energy transfer at any given pressure. The flow rate is also nothing but the amount of energy going to be transferred. Okay, if the flow rate is high, the energy is going to be transmitted high. If the flow rate is lower, the energy transmission is also considered as lesser. Okay, so like that, the flow rate is going to be one of the key factor to control the speed of a actuator. So for to do that, we use the flow control valves. So as in here, we are mainly having the types in the flow control valve. In that, first type is non-pressure compensated flow control valve. Okay, non-pressure compensated flow control valves are nothing but which are not compensated with the pressure. Okay, which have one fixed orifice. You can easily understood this non-compensated pressure valves by understanding the nozzle. Okay, if you use a nozzle in any pipe connection, the amount of liquid which is discharged from that nozzle is fixed. Okay, we can't vary that whatever the amount of discharge. Okay, so that type of whatever the flow control valves are nothing but considered as a non-pressure compensated flow control valve. You can see here the non-pressure compensated flow control valves are used when the system pressure is relatively constant. Okay, there is no such variation of pressure which is going to be expected in the system. So in such areas we can use the non-compensated flow control, and the motoring speed are not too critical. Okay, in some hydraulic systems the motoring speed is very high, some critical high speed we can expect in the motor. So if that type of pressure is there, so the flow control valve increase the pressure. Because of the flow control, the pressure is going to be increased. Okay, so that increased pressure can leads to some abrupt work in whatever the hydraulic system. So that can be avoided if it is having the pressure compensation. But non-pressure compensated valves are used where there is no critical speed is going to be expected. The operating principle behind the valve is that the flow through an orifice remains constant if the pressure drop across it remains the same. Okay, so as I explained, it is just an orifice. Just by reducing the opening of this whatever the opening of that valve, so that leads to a form of orifice. It is fixed. Okay, so because of that fixed orifice, the amount of pressure drop is also considered as same. Okay, so in the non-pressure compensated flow control valve. In other words, the rate of flow through an orifice depends on the pressure drop across it. Okay, the rate of flow through the orifice depends on pressure drop across it. The amount of flow is going to be relatively depending upon that whatever the pressure drop. Okay, So we will see this pressure compensated valve. So first one is the orifice. Just you can see this diagram. So this is a fixed orifice. It's a simple type of non-pressure compensated flow control valve. Okay, it is just you can. This is actually a graphical symbol which is used in your whatever the in a circuit. So this is the symbol. So in here just you can see one line, middle line is there, and you can see the two arcs oppositing in opposite direction. So this formation is nothing but a simple orifice valve. Okay. So next is the needle valve. Okay, it is also a pressure compensated. You can see it is the simplest type of flow control valve. It consists of a screw or a needle inside a tube like structure. Okay, so this is very simple type of whatever the flow control valve. You can see it is having a type of screw which is uh, inside a tube like structure. It is in a inside like a tube like structure, and it is going to be adjusted by using this whatever the threads which are provided on this whatever the shank part of a needle. Okay, it's also called as a needle. It has an adjustable orifice that can be used to reduce the flow in the circuit. You can see this needle is inserted in this whatever the small orifice. Okay, there is a small opening in here, so this can be adjusted. You can see here the first stage you can have the no flow, means it is completely closing the orifice. Second, the B diagram represents the small amount of liquid is passing in here, and at the C diagram the complete opening of the valve taken place. So by that the amount of liquid is discharged high. So this type the whatever the flow control can be achieved in here. The size of an orifice is adjusted by turning the adjustable screw. The rise or lowering the needle. By adjusting the screw we can variate the opening of this whatever the orifice. For a given opening position, the needle valve behaves as an orifice. Means if you have a small opening, so that behaves as a small orifice type of valve. If you have bigger opening, it behaves as a somewhat more discharge. It is also a fixed orifice type of valve. You can see the symbol for this whatever the needle valve. Okay, so in here the same symbol which is given here, only the arrow mark is presented here. This arrow mark represents it can be adjusted. The whatever the orifice is going to be adjusted. That's why it is called as a variable orifice. The orifice of this opening of this whatever the valve is going to be adjusted by screw knob. So this represents the symbol of needle valve. So next, very important, that is pressure compensated flow control valve. It's very important in considering the flow control valves. This is actually a simple type. There is no pressure compensation taking place, and it is used where there is no complication of pressure is going to be considered. It's not that much considered. Pressure compensated flow control valves are used where the pressure compensation is highly needed. Okay, so since the pressure is going to be increases in the system, in the whatever the connecting lines of a system, so those lines will affected by that high pressure, so that can be avoided. Okay, as we know, as the opening of the orifice smaller, the pressure in the system increases. Okay, and the pressure of line is going to be increases, so that should be compensated. Okay, you have to maintain the flow, and you should maintain that whatever the pressure in some normal or some regulated limit. Okay, so that can be achieved by this pressure compensated flow control valve. Okay, you can see the diagram in here. So this is a main spool. This whatever the pressure compensated valve consisting of two spools. Okay, this whatever the eye shaped whatever the things which are seen in here, it is a spool type of shape. This is a main spool, and this is a compensator spool. Okay, so this main spool is going to be connected to the adjustable knob. Okay, this adjustable knob is having the threads. By that threads you can adjust the opening of this whatever the position of this main spool. Okay, so next the compensated spool is connected to a spring. Okay, it is a compression spring. It is connected to a spring. So by this spring action also, this whatever the position of this compensator spool can be adjusted. And you can also see the liquid is passing from A to B. You can see the line which is showing the direction of flow, and you also having the two pilot lines. One is pilot line B. Okay, this is the pilot line B, and you can see another pilot line. This is pilot line A. Okay, so this is the drain line where the liquid, if you leak the liquid which is trapped out here, it can be drained out. Okay, so what happens, this is the construction of this, whatever the pressure compensated flow control valve. So what happens actually when it is working? So the liquid comes here. Okay, the liquid comes here. Before that, the orifice, you can say this is the opening of this whatever the valve. From here only liquid enters to the next system. A to B, the liquid is going to be transmitted. So this valve opening is going to be adjusted. The priorly that by adjusting the knob, the valve opening can be fixed. Okay, this is the fixed position of this whatever the main spool. So what happens? Liquid comes here. It tries to move here. If the pressure increases in this line, okay, as it comes here, it is at a higher pressure, it comes here, but because of the small opening, the pressure increases at here. Okay, the pressure is going to be increases at here. So because of that pressure increase, the liquid comes to the pilot line A. Okay, the pilot line A, because of the increase in pressure, the pilot line A is going to get the pressure, and by that motion, it will pushes this compensator spool to the right side. Okay, the liquid comes here and it pushes the compensator spool to the right side. Because of this pushing of this spool, it will close this orifice. You can see this opening is close this orifice, or it will reduces the orifice. Okay, so as the pressure increases at here, as the flow lessens at this portion, the pressure automatically reduces. Okay, pressure automatically reduces. By the reduction of pressure, the liquid which is transmitted at here, it is going to be having the lesser pressure. By that, because of the action of spring, the spool move right side. So this action continuously happens. So this positioning of this whatever the compensator spool continuously happen as the pressure increases at here. Okay, so like that the liquid is going to be transmitted. The flow is going to be same. The flow which is coming out of this wall is going to be considered same. Only the pressure compensation happens at here. Okay, as the pressure increases at here, the pilot line activated and it will pushes the spool right side and the opening will be reduces. Because of the reduction of opening, the flow is going to be controlled and pressure going to be controlled, compensated at here, and the liquid is going to be, the amount of liquid is same. It will be expelled out of here, it will be same, it will be not be variated. As the pressure increases by the some other reasons, as the pressure increases at this portion, assume the pressure is going to be increased at this portion because of the next system line or next pressure. The pressure increases at here, it will pushes the liquid in this pilot line B, and it is going to pushes the liquid in this portion, and it will push in the opposite direction of the spool to left side. So because of this movement, the spool is going to be in this opening is also controlled by this spool, whatever the land, and the flow is going to be controlled at here. So by that also the external pressure condition is going to be compensated by this pressure compensated flow controller. So like that, this whatever the pressure compensated flow controller works, it is very simple, but continuous pressure compensation is going to be takes place. By that the flow is going to be maintained and pressure is also going to be considered in a regulated manner. So this is the one circuit which represents the flow control valve, where the flow control valves are going to be used. Flow control valves are always used in this position. Okay, this position is between this direction control valve to the actuator. In between the actuator to direction control valve, we use the flow control valve. So whatever the liquid comes here, it will move here. It will experience some flow reduction in here because of the flow control valve, and it will move here. So if the flow controller is adjusted with a smaller opening, the small amount of liquid collected, and it will pushes the piston in a slow speed. Okay, the slow pressure is going to be applied, and by that the piston move in a slow manner. If the opening is higher, the piston move in a faster manner. If the liquid is coming back, then this is actually a single direction flow control valve it is. So it will not allow in this direction. It will allow the liquid, and it will opens the check valve, and by that the liquid is going to be transmitted to the direction controller. So like that the flow controller is going to be used in a system. So next, in one more important type of flow control valve is pressure and temperature compensated variable flow control valve. Okay, what happens? In the earlier we have seen that only pressure compensated flow control valve, but in here we are seeing the temperature compensated, both pressure and temperature compensated variable flow control valve. Okay, it is going to be considered in here. So what happens in here? It's also, you can see here, what are the parts in here? This is the inlet port, this is the regulated flow output, this is compensatory spool, or you can call it as piston. This is adjustable orifice. This is the opening is called as adjustable orifice. This is the temperature sensitivity element. Okay, if we first we see this, because the viscosity of hydraulic oil varies with the temperature, as do clearance between the valves moving parts out of the flow control valve may tends to drift with temperature changes. As you know, as the temperature increases in a system, that will reduces the viscosity of a liquid. Okay, so as the liquid reduces, the viscosity of liquid reduces, that may leads to some improper work of improper pressure. Okay, the pressure is not going to be adequate. So that viscosity is going to be considerably reduces the pressure, and by that the liquid, the whatever the operation of actuator is going to be affected. So to avoid that effect of whatever the actuator by viscosity, we use the temperature compensatory element. Okay, so that is the thing which are going to be used in here. Okay, to offset a orifice, to offset the effect of such temperature variations, the temperature compensator adjusts the control orifice opening to correct the effect of viscosity changes caused by the temperature fluctuation of the fluid. So come to the diagram in here. So as the liquid comes here, it is having the fixed amount of flow output as the liquid comes, and it will go to this direction. But as the fixed output comes here, this temperature sensitive element is constantly sensing the viscosity of that whatever the liquid. Okay, viscosity of the liquid. As the viscosity of liquid reduces, this will tends to closes this whatever the orifice, adjustable orifice, and by that this whatever the liquid which is trapped, its exponential pressure, it will comes here and it will pushes this compensator piston in the left side. This is the spring. It will come pushes in this side, and the opening is going to be increased at this portion. By that the liquid, more amount of liquid comes here, and by that the liquid is going to be maintaining the regulated flow. So as this happens, and if any pressure increases, the liquid comes here and it will pushes here and it will reduce the flow. So like that, the temperature compensation element will help the flow of a liquid to adjust this orifice to maintain the flow. By that flow, it will adjust the pressure of a actuator. So like that, this pressure and temperature compensator variable flow valve is going to work in here. Okay. This is done in the combination of the adjustment to the control orifice of pressure changes as well. It also controls the pressure. We will see the symbols in here. First one is the flow control adjustable. As we seen in here, this is the symbol with the adjustable element. One way flow control valve, as we discussed in the circuit, the liquid comes here in only one way with a flow control. But if the liquid comes in opposite, it will not allow. The liquid had to open the check valve and it had to return to the drain line. So next, flow control with a bypass pressure compensated. Okay, you can see the diagram, the similar diagram compared to this, but only the changes. This is the arrow mark. This arrow mark represents the pressure compensation. Okay, the liquid comes here, the pressure compensation takes place, and the liquid move to the actuator. In the return line, it will not allow any this direction. It will have to open the check valve and it have to move to the drain line. Next is the flow control valve with bypass pressure and temperature compensation. Okay, so the similar diagram, only the variation you can see, the temperature variation, you can the line and a dot. Okay, so this represents the temperature compensation. It is having the both pressure and temperature compensation. So this symbol represents flow control with the bypass pressure and temperature compensation. Okay, so like that, these are the symbols of a flow control valve. So I hope you have got a lot of information regarding the flow control valve, how it is going to work, why we have to make the pressure compensation, why we have to make the temperature compensation, what is the role of flow control valves in the hydraulic system. If you have any doubts regarding this, whatever the flow control valves, you can contact me. Okay, thank you for watching.